All right, hey guys, we're going to finish up lesson 11.3, which is what we started yesterday. I'm going to go over some quick talking points. You'll need some graph paper for your homework, by the way. All right, so quick little warm-up. It says, does this function here have a maximum or a minimum? All right, well, if I look at it looks like this is the highest the graph goes, so it is a maximum. All right, if I label the vertex of that graph, it's negative 1, 2, 3, comma 1, 2, 3, 4, 5. So negative 3, comma 5. It says, what does the vertex tell you about the maximum or minimum? I would say that that's the highest it goes, the highest point on the graph. All right, so yesterday I started talking to you guys about the difference between a quadratic equation and a quadratic function. So a quadratic function is if I have something like this, y equals x squared plus 2x plus 6. A quadratic equation would be something without the y, where it only has one variable, like x squared plus 2x equals 6. So they both have the x squareds in them, okay? But the difference is this one would make a graph, this one wouldn't. But when I solve both of them, the solution to a quadratic equation is basically whatever the x-intercepts are, or the roots, another name for it, or the zeros. Okay, so we learned that we can actually solve quadratic equations by pretending it's kind of like a function, and then solving it just like we would if it was a quadratic function. So let's try one so we can make sure that we feel comfortable doing it. So the first thing you guys might notice is, hey, this looks like an equation. It has an equal sign. There's only one variable. It's just an x. And if I want to solve this, the only way I know how so far, we're going to learn other ways this chapter, is that I want to change it so it looks like this. Y equals, x squared, blah, 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 blah. So I wanted to get it to look like that. So I'm going to draw my line down, and I want everything to be on one side. So I'm going to add 2x to both sides. And I'm going to subtract 80 from both sides. Okay, now here's what I have. I have x squared plus 2x minus 80 equals 0. Okay, well that is helpful because now this looks just like if I would have written it like this, y equals x squared plus 2x minus 80. So I'm going to try to find the two x-intercepts, or the two solutions to this equation, by doing it just like I would if I was going to be graphing that function. So first thing I know, and I'm just making a rough sketch of this, I know my y-intercept is negative 80, so I'm just going to pretend this is negative 80. I'm going to mark that on my graph. I'm going to come way down here. All right, I can next find my axis of symmetry. So I can do negative b over 2a. All right, if I plug that in, my b is 2, so negative 2 over 2 times 1 is negative 2 over 2, which is negative 1. So my vertex is going to be negative 1 comma something. So I'm going to go to my equation, x squared plus 2x minus 80, and I'm going to plug in a negative 1. So negative 1 squared plus 2 times negative 1 minus 80. If I do negative 1 squared, that's 1 plus a negative 2 minus 80. So if I do 1 plus negative 2, that's negative 1 minus 80 is negative 81. So my vertex is negative 1 comma negative 81. Now I can get another point right here. So far, pretty good. Now I want to try to find my two x-intercepts, or my two roots, because that is really the solution to that. So I'm going to try to factor this to find the zeros. So I know it's x and x. Now I need to figure out what times what is negative 80, but when I add, I get 2. Okay, so I'm going to try to kind of think, well, what times what is 80? Well, 40 and 2 is not going to make a 2. I think 8 times 10. All right, so I'm going to do 8 times 10, and it looks like it needs to be a negative 8. Okay, so I just kind of did that part, and I end up with x minus 8 and x plus 10. So now to find my x-intercepts, or the solutions to this original equation, if I plug in an 8, that would make that equal 0. And if I plug in a negative 10, that would make that equal 0. So there are my two x-intercepts. So I would have to go to 8 and negative 10. Now I have my parabola, which is good. I can sketch it. But then my solutions to this original equation up here, what could you plug in that would make this true, are x equals 8 and x equals negative 10. All right, so this next one, I'm not going to solve all the way. I just want to talk about it. Again, it's an equation. You could solve it by graphing. I'm going to move everything over real quick. So add 24x, add 72. So I end up with 2x squared plus 24x plus 72. Now, before you would do anything, first thing I would say is, hey, okay, my y-intercept is 72. So way up there. My next thing I would do, you could find your axis of symmetry. But then when you get to the factoring part, you always want to see, is there something you can divide out? Just like if there was a negative here, I would divide out a negative. If there's a number that goes into each of them, you're going to want to divide that out. So I would rewrite that as 2, and then I would do x squared plus 12x plus 36. Now I would try to factor that, okay, and then I could come up with my x-intercepts. So I just wanted to show you guys that real quick. If there's something you can divide out when you get to the factoring part, do that. Now, this does not mean that your y-intercept is 36. That's not the case. It's that original 72, so just be careful with that. All right, let's do one more real quick. So I have this problem. Again, it's an equation. I'm going to solve it by graphing using what we know about functions. So I'm going to just move that 15 to the other side. So now it says negative 3x squared plus 2x minus 15 equals 0. All right, first thing I know is my y-intercept is negative 15. Second thing I'm going to do is find my axis of symmetry. So I'm going to do negative b over 2a. So it looks like negative 2 over 2 times negative 3. So I get negative 2 over negative 6, which ends up being positive 1/3. All right, so this is not a real nice one, but it's positive 1/3. So my vertex is going to be 1/3 comma something. We're just going to estimate when you guys do this. So when I plug this in, I have negative 3, and then I have 1/3 squared plus 2 times 1/3 minus 15. So I'm going to get negative 3 times 1/9 plus, this ends up being 2/3, and then minus 15. Okay, if you work that out, this ends up being negative 3/9 plus 2/3 minus 15. Now, I did show you guys where the fraction button on your calculator is, so I'm actually going to type that in. So 3/9 negative plus 2/3 minus 15 equals negative 14 and 2/3. So there is my vertex. So it's 1/3 comma negative 14 and 2/3. So if that's my vertex, it'd be right there. Now I can get that other point across from it. I know it's going to be going down. So already I want to think to myself, hey, is there going to be any x-intercepts? There is not, okay? It's going upside down, so there are no x-intercepts. So right now, you could try to factor this. It likely would not factor, which is why there are no x-intercepts. But you wouldn't even have to get to that part if you did it by graphing and got your vertex first and then knew, hey, it's going down because of the negative, then I know there are no x-intercepts. All right, so you guys are going to be doing some problems in your, I posted these in Schoology. Ignore the highlighted ones. I listed the ones you guys need to do in Schoology, so you're going to be doing these on graph paper and showing your work in your notebook or right next to it on the graph paper. You will submit a picture when you are done. So you have the rest of the time to try these. If you get stuck, ask somebody at your table, and you can look at the answer key as well. By the way, you are doing numbers 1, 2, 3, 5, 6, 7, and 9. Okay, so those are the ones you were doing. So basically, you get to skip 4 and 8.